In this video, I will give you some tips using which you can quickly convert a non-terminating recurring decimal to its equivalent fraction. In a previous video, I had shown an algebra-based formal technique for the conversion. But the question really is, can we avoid the algebra? The answer is yes, and I intend to show that in this video. For arriving at the tips, I will be referencing the algebra-based technique. However, I will not be going into details. If you want a more detailed explanation of the algebra-based technique, I suggest you watch that video first. Let us now look at a few examples. The first example I will take up is 0.3 recurring. Here we have a single digit which recurs after the decimal point, and this is the formal technique for finding the fraction equivalent of 0.3 recurring. Let us do a quick walkthrough of the technique. We let x equal 0.3 recurring and multiply this equation by 10 to get 10x on the left hand side and 3.3 recurring on the right hand side. We subtract the two equations to get 10x minus x on the left hand side, and on the right hand side we have 3.3 recurring minus 0.3 recurring. 10x minus x gives us 9x, and on the right hand side we get 3, and hence x equals 3 over 9, and 3 over 9, or its simplified form 1 over 3, is the fractional equivalent of 0.3 recurring. Now if you look at the non-simplified answer, the numerator is the digit which recurs and the denominator is the coefficient of 10x minus x, that is 9. Which means to find out what is 0.3 recurring, all we need to do is to write the digit which is recurring, 3 in this case, in the numerator, and in the denominator we write 1 less than 10, that is 9. We can generalize to say that 0.4 recurring would be 4 over 9, 0.5 recurring would be 5 over 9, and so on. Let us now look at what happens if there is more than one digit in the recurring sequence. Let us start with two digits in the recurring sequence. Say we have 0.47 recurring, which has two digits in the recurring sequence. From our algebra-based technique, we can see that we had to multiply our original equation by 100 instead of by 10 as in the previous example. Now if you look at the final answer, we can see that here also the numerator consists of the digits in the repeating sequence, and the denominator is the coefficient of 100x minus x, that is 99, which means 0.47 recurring would be the digits in the recurring sequence, that is 47 over 1 less than 100, that is 99. We can generalize to say that 0.65 recurring would be 65 over 99, 0.87 recurring would be 87 over 99, and so on. What if we had three digits in the recurring sequence, say 0.687 recurring? It is easy to see that our numerator would be the digits in the recurring sequence, that is 687, and our denominator would be 1000 minus 1, that is 999. So all we need to do is to put the digits in the recurring sequence in the numerator, and for the denominator count the number of digits in the recurring sequence and put that many number of nines. Now that we have looked at the simple cases, let us look at a final example, one where we have a repeating sequence which doesn't immediately start off after the decimal point, say 0.547 recurring. We can write this as 5.47 recurring divided by 10. Since dividing by 10 will shift the decimal point to the left by one place, resulting in our original number. Let us first look at what is 5.47 recurring. 5.47 recurring can be written as 5 plus 0.47 recurring. we finally have something which we know how to handle. 0.47 recurring equals 47 over 99. So we have 5 plus 47 over 99. This equals 5 times 99 plus 47 over 99, which equals 495 plus 47 over 99, which equals 542 over 99. We need to find out what is 5.47 recurring divided by 10. This equals 542 over 99 divided by 10, which equals 542 over 99 times 1 over 10, which equals 542 over 990. And we have our answer, which can be simplified further if required. In this video, I presented some tips for quickly converting a non-terminating recurring decimal to its fraction equivalent without using algebra. I hope you found this video useful. If you have any comments or suggestions, please leave them in the comment section. Also, if you feel that someone you know can benefit from this video, please share with them. If you are interested in more such videos, please subscribe to my channel. Thanks for watching.